Hey everyone, this is an ESP32 voice memo recorder that I made, and before I go over the details of how I made it, I'm just going to give a quick demonstration. So basically the user interface consists of a joystick and an OLED screen. So if we want to record something, we scroll down to record and press the joystick button. We are from Earth, we come in peace. And now, if we want to play it back, we scroll down to play and we can press the play button.
We are from Earth, we come in peace.
And then, if we want to do speech to text, we press the joystick to the right and we get the next menu. And we just select the file, which I think is this one. Let's try it anyway. We can play it by pressing the button. Oh no, it's not that one. So the file I just recorded, I think, is this one because it's the one with the highest number on it.
We are from Earth, we come in peace.
Alright, and then to translate it, we go to the translation menu and we can do French or Italian, and the Chinese doesn't work because I had difficulty displaying the Chinese characters to the OLED screen, even though I can print them to the serial monitor. So let's try French. So first it's going to come up with the English text, and then it's going to do the French translation. So it says, we are from Earth, we come in peace, so that's fairly accurate. And then I'll press it again, and hopefully we'll see the French. Okay, so I think that says we are from Earth, we come in peace in French. Alright, so now I'm going to take you through exactly how I built this and designed it. Okay, so I'll see you in the next scene. Today I'm going to make an ESP32 voice memo recorder that uses I2S. So the first thing I'm going to need, of course, is an ESP32, and I'm going to need an SD card reader just to store the voice memos on, a microphone. This is an INMP441 MEMS microphone, Max 98375 amplifier. I've got some 8 ohm speakers, and for the user interface I'm going to use a joystick control and an OLED screen. So I'll put all that together and we'll see how that goes. It's always a good idea to test your components individually, or parts of them individually, before you wire everything together, because it makes troubleshooting a lot easier. So before I do the I2S stuff, the recording and play stuff, I'm going to test the user interface with the joystick and the OLED screen. And I'm just going to wire that together and see how that goes. So I'll put a little demo sketch on here just to get the analog joystick working with the OLED screen. So all this does is it just scrolls through circle, rectangle, triangle, and rounded rectangle, and then it draws each one. So if I go to rounded rectangle, I can draw a rounded rectangle or fill rounded rectangle. So I press the button and that'll keep drawing it until I press the button again, and then it'll go back to the menu. Or I can choose fill and then press the button and that'll keep filling it until I press the button again. And then I can press left to go back, fill circle, press to go, press to stop. So those are the commands, and so I'm going to integrate this now into the voice memo recorder just to record, play, and select files to play back. I'll take you through the sketch now that I'm using to demonstrate the analog joystick OLED control demo. But before I start with that, I'll just give you a quick overview of how I've got it wired up. So I've got the horizontal and the vertical outputs from the joystick connected to pin 34 and 35 of the ESP32. And the reason I've used pin 34 and 35 is because they've got analog to digital converters on them, which are usable. The button is connected to pin 15, and I've just used pin 15 because that was a spare. And the OLED is on the I2C bus, so it's pin 21 and pin 22, which are the default I2C bus pins on the ESP32. So in the sketch, I've basically got two tasks running. One to get the joystick data, so that monitors the state of the joystick, and then this passes the state of the joystick to the run menu command, to the run menu function, which then decides which menu to display and what function to call from the menu. So having these tasks in FreeRTOS is a bit like having an extra loop. So in our normal sketch, we'd have a setup and a loop, but if we had like a loop 2 and a loop 3 running at the same time, simultaneously to the loop, it would be the equivalent of having these FreeRTOS tasks. So I'll just take you through the setup. So the loop, I've actually deleted the loop. I don't have the loop anymore. I just run the two tasks as my two loops. So the setup. So the first thing that happens of any significance in the setup is we initialize the menus. So the menu, I've just defined this as a structure. So for this demo, there's 5 menus. So there's first menu, which is like the opening screen, and then second menu, which have options to second, third, fourth, and fifth menu, which have the options to draw the shapes on them. So the most important thing in the menu is the menu options, which I've just defined as a string. So all the menus are instantiated here. So all the menu items are in a single string, and they're separated by a \n control character. I'm only using the \n as a separator. I'm not actually using it in my print functions. And I originally was, but I changed that. But I just kept it in there as a separator. So now I initiate the display. And all this does is initiates it on the I2C bus, basically, initiates the communication. And then I display the first menu. So the first menu is like the opening menu. So this just writes the menu to the OLED screen. So I'll show you the picture here. So this is the first menu. So this is the menu that comes up. And we see this little greater than sign in front of the circle. That just means that the circle is like the active item in the menu. So that's the item that's going to get selected if you push the joystick to the right or left or push the button. Now, if we push this to joystick down, we go down to rectangle. So now the rectangle is the active item. So let's go back to our sketch and see what happens when we push it down. So we're monitoring the joystick, and each time we read it, we push it down, we get a down, and then we send this down here to our run menu function. And our run menu function receives the down over here. And if it's different from the previous command, if we get two states of the joystick in a row that are the same, we don't do anything. And the reason is that because in the time it takes you to push the joystick down and then let go, it's going to actually send about 5 of these commands because the processor is a lot quicker than your finger. So if it receives this menu down, all it does is it updates the pos, it increases the pos, which just increases the position. The pos is just the position of this greater than sign on the menu. So it just, and also the rectangle is now the selected item. Basically, it's the active item of the menu. And when we push the joystick to the right, we get these options to draw a rectangle and fill rectangle. So the next thing we do, once we've got this option here, is we press the button and we draw a rectangle. So I'll go through that in the code. So now the button is pressed, so that's a push. So it sends the command push to the run menu function, and when it receives push, it calls this function do stuff, do it. And do it is whatever item is highlighted on the menu. So do it is a string which has draw rectangle, draw rect basically, because this one has the greater than sign in front of it. So now if we go to the do stuff command, the do stuff function, so the first thing we do is we wait for the button to go high, which means that it stopped being pressed. Because if we press the button and it's taken us longer to take our finger off the button than it's taken to get to this function, we're going to think the button is still being pressed. And the other thing we do is we define a semaphore here. So the semaphore basically means we take control of the joystick. So if we have a look at this function here, this has a semaphore. So a semaphore is like a talking stick. So say we've got two people in a room and they both want to talk, and to stop them both from talking at the same time, one of them has a stick. So the person with the stick gets to talk, and then when they're finished talking, they give the stick to the other person. So what this does is when this function doesn't have control of the semaphore, it can't do any of this stuff. So this means that we can use the joystick again here, because now we've taken the semaphore, we can read from the joystick, and we won't have to worry about, if we press the button, we won't have to worry about that command going to the run menu function. It'll only be read inside this do stuff function. So once we press the button, this is while the button is high basically. So while the button isn't pressed, and then once we press the button, we return to the menu. So we keep filling the rectangle, keep repeating that until the button is pressed. So we've sent the string draw rect, which is here, draw rect. So what this does is it calls this function test draw rect, and it keeps on doing that until we press the button. And then we return back to the menu. That's basically all there is to the sketch. And if you've got any questions or suggestions for improvement, please leave them in the comment, and I'll see you in the next scene. I've wired up the voice memo recorder, and there's the joystick that controls the OLED, and then there's the speaker. So I've already destroyed a couple of these speakers by turning the volume up too high. So I'll just show you how it works now, and then I'll take you through the code. So I just push the joystick down to record, and then when I press the joystick button, it records. We are from Earth. We come in peace. And then stop the recording by pressing the joystick button again. And then if I press play, I can push the joystick to the right and see the files, or I can press play and it will play the last file recorded. So I'll just press play.
We are from Earth. We come in peace.
And then the other thing I can do, so I select the file. Well, this isn't implemented yet. And then if I press the joystick to the right, I can select the language that I want to translate it into. So I can do speech to text. Well, I haven't done that yet, but I'm hoping to implement that in the next scene. So I'll take you through the code now, and then I'll try and implement the speech to text after that and the translation. Before I go through the code with you, I'm just going to go over the work of some other creators. And the reason I'm going to do that is because this is a very important part of my development process, and because these guys explain I2S really well. But more importantly, because I've used a lot of their code. I've used a lot of their code snippets in this project. Now, Bill from DroneBot Workshop has a really good article which explains all the ins and outs of I2S. And there's a couple of sketches in this article which are really well worth trying out. One for the microphone and one for the amplifier. So this is the microphone sketch. And the reason you should try these out is just because it makes sure that the microphone and amplifier are working properly before you wire it into your project. So if you wire everything up and then something's not working, it's going to be a hassle to find it. Whereas a lot of problems you'll be able to troubleshoot by just loading up these sketches. So this is the one here for the amplifier. Now, you don't have to follow his pin configuration. It's probably best to work out what pins you want to use before you start the project. Now, the next project I looked at was from that project, Eric Nam from that project, who has a really good tutorial on capturing audio from I2S microphone and saving it to a WAV file. And he goes through everything in the WAV header as well. And then his code is all written in C, and it's all just in one file. So you've got everything there in one file, which is fairly easy to basically dig into and get under the hood of. So then Xtronical has a project on playing. So for the recorder, for the voice memo recorder, I needed to put these two together. So I needed a record and a play, and I needed to put these two kind of together. So I used the code from Eric for recording, and the only thing I had to change was the sample rate. So he uses 16,000 and I wanted 44.1 kilohertz because at 16 kilohertz it sounds like you have a lisp, and for voice recording it doesn't really come out that well. So I had to change that, and then I used this code from Xtronical for my player to play the sounds. But then the issue is, how do you put them together, all right? Because you've got the I2S, how do you configure the I2S to both play and record at the same time? And it's not as easy as you'd think. So the first thing I did was I asked GPT Chat, and GPT Chat told me to install the driver, the I2S driver, for the recorder and the I2S driver for the player on different ports. So I tried doing that, but I got a guru meditation error and it panicked on call 1. So that didn't work. So, and everywhere I looked had everything configured on port 0 for this. So then I went to Atomic 14, who said one of his commenters had a nightmare trying to do this, so he decided to do it and he got it working. And the secret, so Atomic 14 gives all his code. He gives code for both Platform IO and IDF. And his code is written in C++, so it's all object-oriented. It's a lot more slick, but it's kind of more difficult to get under the hood. But if you look through his code, you find the secret to getting both of these working at the same time. So basically, when he does the play, he has to start, which basically he has to install the I2S driver, and then when he finishes playing, he has to uninstall the I2S driver and clear the outputs. And similarly for the record. So by installing and uninstalling every time you want to record and play, you can get both the record and the play to work at the same time. And now the other thing that Atomic 14 does, Chris from Atomic 14, is once he's finished recording, he rewrites the header to the file. So he seeks the 0 position and then writes over the header that he's already written, because you don't know how long the file is until you finish recording. Whereas with Eric's code, he just assumes that you're recording for 20 seconds. So he's able to write that he's able to write that at the start. So this is Jonathan from the future, and I didn't actually end up using the code by Xtronical. I ended up using the code that is in the ESP32 Audio I2S library for play. And the reason I did that, I mean, the code in the Audio I2S library, the reason I didn't originally want to use it was because it takes up a fair bit of program memory. But I decided to go with this code, and the reason is because in Xtronical's code, when I play it, it was playing at twice the speed. So if I said something like, you know, we are from Earth, we come in peace, or saying, we're from Earth, we come in peace, you know, so I had to, as a fudge, just cut the sample rate in two to get it to play at normal speed. But then it was quite noisy. It was like it was missing half the data, so I didn't know what was going on with that. So I just went back to the audio library that's used in the DroneBot Workshop article, and that seemed to work quite well. I'm briefly going to go over the code for implementing the voice memo recorder, and I've done a fritzing diagram as well, and I'll put that up on GitHub so you can see what all the connections are. So the code is built on the joystick OLED code that I went over before. So when we press the button on the joystick, it'll do the recording or playing. So say we've got play highlighted and we press the button on the joystick, and then it'll send the play command to the play function, which will then play whatever file is on the SD card. So I'll go over that with you as well. Okay, so in the setup routine, first thing I do is I just light up the green and red LEDs just for 1 second, just to make sure things are going okay. Then I initialize the SD card. So all that does is connect the SD card to SPI. I initialize the wave header, which is the header I use for recording, which is in here, this wave header here. And this one I got off Eric Nam's GitHub repo. And the only thing I had to change these lines here to get it to record at 44.1 kilohertz. Because he had it set to 16 kilohertz. So once I changed those lines there, it worked quite well. Okay, and then I initialize the menus, and then I get the latest SD file name, which is the one with the highest number appended to it, and I set that as the file name. So when I press play, it's going to play the last file recorded. I initialize the displays, and then I start so this one here is the run menu, which takes the commands from the joystick, and this one here is the joystick menu, which gets the input commands that you input to the joystick. And then this clear I2S driver, that's fairly important, because what happens is when we have our play, we're using this audio object here, which is from the audio library, which is actually a very good library for audio, for playing audio. So when this object here is instantiated, it automatically installs an I2S driver. So what we have to do in our startup function, our setup function, we have to uninstall the I2S driver. And the reason we have to do that is because the I2S driver is installed for playing, but if we want to record, then it won't let us record with that I2S driver installed. So once we've done that, we just delete the loop because we're using these tasks, the FreeRTOS tasks. We're just running two FreeRTOS tasks basically, which take care of everything. One FreeRTOS task which gets the data, reads in the data from the joystick and sends it to this FreeRTOS task which runs the menu, basically the OLED menu. So what happens is when we press play, let's say we press play, our menu is here, and it gets the push, right? So that's the push command, and it sends whatever is highlighted to the do stuff function. So I've just called this function do stuff for want of a better name. So do stuff, do it is just the string play basically. So it sends it here. So this OLED function receives the string play basically. So we have do stuff play, and that's our input basically. And then we see which we've got. So if it's record, no, it's not record. Okay, so the first thing we do is we take control of the joystick from the joystick input function, and the reason we do that is because we might want to use the joystick for other things. So say we're using the button on the joystick to stop it from playing, but if we press the button on the joystick, it's going to think it's a push and it's going to implement whatever's on the screen here. So say we want the joystick all to ourselves, the controls, we take the semaphore, which just basically means we've got control of the input controls, and then we wait for the high, well, the low on the button press to clear, because we've pressed the button and it's come to this function. But because it comes to this function a lot quicker than we take our hand off the button, we've kind of got to wait for us to take our hand off the button. So that's what just this while loop does. And then it sees what it's being sent, so what the string here is, and we're being sent play. So if it's record, then it records, and if it's got a .wave in it, which means it's a file off the SD card, then it sets that file name to the string, sets the file name to whatever that string is, and then it calls the play function. And so now we've called play, so we go to I2S play, which is in here, I2S play memo. So that relies on this audio object, and then these are our pins for the amplifier here, and I've defined all the colors as well. So whenever I write code, I always have all my wires color coded as well, and I put the color there, and it just makes it so much easier when I'm unplugging things and connecting things and that kind of stuff. I mean, if we have a look, that's it there. There's just so many wires sticking out. So just to stop us from getting muddled, okay, you can see the photo here actually a bit more clearly. There's just so many wires sticking out that we're just going to get muddled otherwise if we don't color code them all. At this stage in the setup function, we've uninstalled the I2S driver, so we have to reinstall it basically. So we have this function here, which is this function here, I2S init play. There we go. Which reinstalls the driver for us with all the statistics that we need. So the I2S play, we install the driver, first thing we do. Then we turn on the LED, so we turn on the green LED, so the play LED is the green LED. And then we set up all our inputs. We set the pin out for the driver because if we've been recording or something, then the pin out won't be set. And then we connect to our file name, which is this audio connect to SSD. It's really simple, and it comes with this library, and it's very simple to execute. And then we make sure the button isn't being pressed, and if it is, we wait till it's not being pressed anymore. And then so while is running, it's going to be true either while the audio is playing, which means we're not yet at the end of the file, or if we press the button. So if we press the button on the joystick, which is this signal here, then it'll stop the audio and return to normal programming. And then the last thing we do, or a little exit this loop here, and then the last thing we do is we uninstall the driver again. So this is really important. I can't stress this enough. The first thing we do, install the driver. The last thing we do, uninstall the I2S driver. Otherwise, we can't play and record at the same time. We can play but not record, or record but not play. So each time we want to make sure we do this. Okay, so now let's say we pressed our play function. What happens if we press record. If we press record, we go to the do stuff with the record option. So record option. So we come into this if block here. So we set up a new file name and we increase our file number, and then we open our file for writing and we write our header, and then we start recording. So we've written our header to the file and now we're recording. So our header is like at the beginning of the file, and then all our data is at the end of the file. So we go to record memo and it's 20 seconds. So this decides how this is like one of the parameters that's in the header. So what we do, we initialize our record, which is basically installing the I2S driver for recording. Where is our record? Okay, so I2S driver, initialize record. We make the recording light high, which is the red LED to indicate that we're recording. Initialize record, which is installing our I2S driver. And now all this code here I got from Eric Nam. This function here I got from Eric Nam's GitHub, and I'll link Eric Nam's stuff in the description because I think it's really worthwhile, and I think a lot of his stuff really is, and I've learned a lot from him. And the other thing I'll say is that this init record and clearing the uninstalling the driver at the beginning and the end, that I got from Chris at Atomic 14. So these two guys have really helped a lot with this project. So I record, and then so basically I record for 20 seconds. So this says basically while we're less than 20 seconds is what this really says. But if I press the button on the joystick, then I break, then I stop recording. So I record for either 20 seconds or until I've pressed the button. And then what I do is I have to rewrite the header. So I have to go to the beginning of the file, seek to the beginning, and rewrite the header, because I might have recorded for a different time than I said I would, than the 20 seconds. So if I stop prematurely, then I'm going to need a different header. So I have to rewrite the header at the beginning. And then I close the file, I free all my memory, I uninstall the I2S driver, turn the red light off, and then I can go back and my file will show up on the SD card. So this one here, is it? Yeah, so then when I go and have a look at all my files, I can scroll through them and I can play them back if I want. So the next step now is to implement the speech to text and the translation. So hopefully that'll work out, and I'll see you in the next scene with that implemented, I hope. So fingers crossed I get that right. I'm going to use the Microsoft Azure resources for the speech to text and the language translation for the voice memo recorder. And the reason I'm going to use this is just because I have an account, and if you sign up they give you some free credit. Don't give them your credit card details or anything, because once you've run out of free credit they might start charging you. But I've used this a few times and I've never run out of free credit yet. Alright, so the first thing we need to do is we need to create a cognitive services resource. So cognitive services, and now we create the resource. Just create and follow the steps. It's all quite self-explanatory. If you don't have a resource group, you'll have to create a new one. I'm in Australia. Name is my resource 4. Okay, my resource 4. Then pricing tier, acknowledgement, review and create, and then you have to wait till it comes up. Okay, go to resource, and then for the API you're going to need a subscription key. So you can click here and this will give you your subscription key. And then you copy this to the clipboard and you'll need an endpoint and maybe a location, and then that's really all you need. And then you can start programming with the API. And there's a few examples they give you here, and on this GitHub they have some examples in there. But I'm going to provide some code just to do this with the ESP32. I've got the voice memo recorder set up now to do speech to text and as well to do language translation. So the way it works is it does the speech to text first to English, and then it sends the English back to the Azure for language translation. So everything's done on the Azure server. So let's try French. So first it'll come up with the English. Let's play it first actually to see what we're doing speech to text.
We are from Earth, we come in peace.
Okay, so that was me saying we are from Earth, we come in peace. All right, now let's do the French. So first it's going to come up with the English. So it says we are from Earth, we come in peace. So that's exactly right. And then press the button again and hopefully it'll do the French. So that's the French there. And then press the button and it'll take us back to the menu. Now let's try the Italian. I've also set it to do Chinese, but I couldn't get the Chinese characters to print to the OLED. Okay, so that's the English. And now it should take us into the Italian. So that's the Italian there. So I'll take you through the code now and we'll have a look exactly how I've implemented it. So I'll see you in the next scene. Before I go, I'm just going to give a quick overview of the code that I'm using to connect to the Azure resources. So this is based on code from Eric Nam, who gives a great tutorial on speech-to-text powered by Google Cloud Machine Learning, but I'm using Microsoft Azure. Now on their Microsoft Learning GitHub, they give a tutorial on how to use the Azure for both speech-to-text and language translation. And it's they give an example in like a PowerShell script. So basically I've taken Eric's code and I've used the parameters from their PowerShell script and I've put those into my code to communicate with the Azure. So for example, headers.add here, all I have to do is go to my code and then it's the same as client.add header. So it's quite simple just to find out what parameters I need. So now I've defined two functions. One called upload file, and this uploads the WAV file and gets the text back. And then the other one, translate, sends the text to be translated. So for the upload file, I'm using an HTTP client to handle the communication between the ESP32 and the Azure resources. The URI I got from the Azure tutorial. So if we have a look at this, we have an option here to define the language that we want to translate, that we're speaking in. So if you're speaking in a different language, you might have to change that. And then of course you've got to give them your subscription key, just like a security thing. And then you define your header. The content is a WAV file, and then you use this function. This I got from Eric's code, client send request, which is equivalent to this function here, write host, invoke web request, invoke web request method post is equivalent to this client.send request. And I just post the file, and then I get a response, and the response is basically the file translated. So this is my response here. Let me just widen this a little bit. So this is the response they gave me, and I've just put that in as a comment so we know what to expect. And it's got recognition status, which is success. Offset, I'm not sure what that means. Duration, and display text. So that's the one I want. I want the display text element. So I do a JSON deserialization with the JSON library, and then I just take the text, the display text element of the JSON document, and that's what I print out to my OLED screen. And then once I've assigned this text, so this text is like a global variable in the file, so the translate function can then just grab that bit of text and send it for translation. So the translate function here again uses the client for communication between the ESP32 and the Azure server, and it translates into, so here's the parameters, so from English to French. So you need these codes basically in your URI string that you connect to with the client. So you connect here to this URI, and that's how it knows what language you're translating from to. Here, so from English to French, and to Italian, and to Chinese. So then it returns a JSON object. So this is translating hello. So the first element of the translations array is the French bonjour, the second element is the Italian ciao, and the third element is the Chinese ni hao. And then it displays the text you've just translated on the OLED screen here, and then display to get the OLED screen to show it. And then it finishes, it closes the client, and it frees the temp. Okay, so this temp1 is like a char array. So when I do the speech to text, I bring it back as a string. I put it into a string, which just makes processing a bit easier. But I need to send this then to Azure as a uint star, so as an array of unsigned 8-bit integers, which is really just an array of chars. So I transform this into a char array here, and there might be a better, I just go iterate through character by character and pop it into this array, and there might be a better way of doing this, but this was just really just the quickest way from a coding point of view for me to do it. So that's that. And then the other thing, I guess, is this Wi-Fi Connect, which doesn't really do anything, but when I was trying to get this to work, when I implemented this part, the record part of the voice memo failed, and the reason it failed is because it was using too much memory. So I couldn't have the record function running and connected to Wi-Fi at the same time. So I was connecting to Wi-Fi and then disconnecting before and after each transmission to the Azure resource, and that was the only way I could get the record to work. But now I've set this reconnect here to false, so this won't do anything. But the way I solved that was I went to the record, and the buffer, which basically the buffer here, which basically buffers the sound, was set too large. So I had it set at 64. So 64 buffers of 1K each. And then I set it to 32, and that reduced the memory, which solved my memory issue. So I didn't have to disconnect and reconnect the Wi-Fi anymore. Okay, so that's about it. And if you've got any questions, just put them in the comments. I'm happy to answer. Everything is available on my GitHub repo. And hopefully I'll see you in the next video.